Okay, assalamualaikum and good morning. So today I'm going to show you a bit about on how to calculate the reliability testing, and we are going to do this exercise by using the set of data that have been given in your notes. Okay, so based on your notes, these are the data that we have. We have PI, long passing, short passing, cross left, and then we have first analysis, and then we have second analysis. So this is actually an example of what we call it of intra-tester. Okay, a test that we conducted by one tester which observing the same match twice. So based on this data, what do we need to have first? Okay, the first analysis we are going to change that into x, second analysis into y, and then we need to add on x squared, y squared, xy, and finally mod. Okay, modulus. So what is mod? I'm going to talk about it later. Okay, next one we are going to add on sum at the bottom. So the first task we are going to fill up this table first. Okay, so for the first one, sum of the first one pi is actually how many pi do we have uh, in the in the cases. So in this case, we have 4 pi. So the sum of pi will be 4. Okay, next, we are going to calculate the sum of x. Okay, this will be calculation the sum of x. As for you, you need to do it manually, okay? This is the sum of y. Okay, we're going to put sum of y in here. And then we are going to calculate x square. We have the x multiplied by another x. So that will be x square. And then we have the sum of y square. That will be y multiplied by another y. Okay. And then we have, oh, sorry. And then we have sum of xy, which is x multiply with y. All right. Afterwards, we are going to calculate the sum for the line of x squared, the sum for y squared, and the sum for xy. Okay, as for the modulus, right, what modulus talks about is this one. Okay, let's draw something. Okay, so modulus here, it represent distance. For example, between 10 to 12, the distance is 2. Same goes from 12 to 15. The distance is 3. Okay, it doesn't really matter whether the starting is smaller compared to the ending, or maybe 28 to 20. So the distance is 8. This is modulus. Okay, so please remember in modulus, there are no negative value. Nada. Okay. So for this one, modulus, we are going to see the modulus between x and y. So 24 and 22, the modulus is 2, modulus is 8, the modulus is 1, and the modulus is 0, where the final one is 11, the sum of modulus. So guys, this box is the first step for you to answer, okay, for you to answer the inter or intra-tester reliability testing. So this is the first step for you to conduct test reliability testing. Okay, next one we are going to translate or transport all of this value into the equation. Okay, so the equation will be r equals to n. This n representing here n summation of xy minus summation of x time summation of y. Divide by n summation of x square minus summation of x square. So we have square root of this time with n summation of y square minus summation of y square. Okay, square root of it. So we are going to substitute all of the information that we have above into the equation. Okay, so I'm going to put it here as r, okay, equals to, okay, r equals to, okay, so n we have here is 4, okay, in bracket summation of xy is 4867, 4867, okay, and then minus with summation of x, which is 114, time summation of y, which is 103. 103. Okay, and it will be divided with, okay, it will be divided with, got some s. Where is my formula? I don't have it in here. One function, one function. We are going to divide with the square root of n, okay, 4, divide by summation of x square is, we are going to take a look here, x square, 5474, minus with summation of x, which is summation of x, we have 114 square. Okay, 114 square, and then time with the square root of n, which is 4, summation of y square, 4329, minus 103 square. Okay, so that will be the basis of our equation. Okay, so based on here, let's calculate those things. I'm going to calculate this one manually. I'm not going to use the function formula from Excel. Okay, so I'm going to calculate this normally. So let's do it step by step. For the top, okay, let's change this one into that one. Okay, so we have 4 time with 4867, then we're going to minus that with 114 time with 103, and the answer is 7726. So we have here r equals to 7726 divide by, okay, for the bottom part, let's take the bottom part. Okay, so the first bottom part is for x. So we have here a square root. Where is my square root? Okay, here is my square root. Square root. Oh, okay, sorry. Square root of. Oh, okay. If that the case, we are going to write the equation first. So we have here is 4 times 5474. Okay, minus this one will be 114 square. Okay, we close things up. All right. Then we square root things. So we have 94.34. Okay, so the first part will be 94.34. Now let's calculate the second part, which is, okay, let's calculate the second part. 4 times with 4329 minus with 103 square. Close and double close it. And then we put square root. So we have 81.90. Okay, we have it 81.90. Okay, now let's finish things up. We have 7726 divided by 94.34 times 81.90, close the bracket, and equal with 0.99. So we have here R equals to 0.99. Okay, based on here, we know that the R value is showing a high relation, which indicating it is quite high in terms of relationship between the first and the second reading. So to further things up, we are going to calculate its percentage of error. Okay, and to do so, we are going to use this equation. Okay, percentage of error equals to summation of the modulus between x minus y divided by total mean, which can we find from x plus y divided by 2. This is a formula for total mean. Okay, this is a formula for percentage of total error. This is just to I just speed things up. Okay, and then multiply by 100. Okay, so we have at the top the value of mode. Okay, we have here the value of mode, right? So this value of mode 11 is actually representing the top part. All of this is that one. Okay, all of that is that one, the summation of mode. So this is the summation of mode, or else you need to do it one by one lah. 22 minus 24, the answer will be plus by 68 minus 60, and then 15 minus 11, 15 minus 14, 7 minus 7, and you are going to get 11. Okay, so after that, after we have 11, okay, what we are going to do is actually, we are going to put it as, okay, the summation of mode. Since you have the table, we can use this one. Okay, divide by total mean is 114 plus 103 divide by 2. Okay, divide by 2 times 100 equals to, we have here 11 divide by 114, 103. Now we have 217. So 217 is, we divide by 2, we have it 108.5 times 100. Then let's take our calculator. 11 divided by 108.5 times with 100. 10.14. Okay, we have it here, 10.14%. So this is showing you in between the first and second reading, you able to accumulate 10.14% of error. Okay, so there are some books said that we can actually take until 10%. There are some books say that 5% and below is better. And there are also some other article that said 15% is the highest number of error that we can take. Okay, but for this class purposes, I'm going to take 10%. So what does it mean? Okay, let's say we have two analysts. We have analyst A with R equals to 0.99 and error equals to 10.14%, and analyst B with R equals to 0.98, but the percentage of error is, let's say, 5.6%. So we can see that based on these two reading, both of the analysts did able to show that both of them is actually quite good analysts with uh, intra-tester reliability, very high relation, but the least amount of error representing the better one. So we can say that analyst B is better in terms of this simply because it show less number of error compared to analyst A. What does it mean? It means that analyst B is much more reliable and he can actually observe a video over and over and over again and yet still come up with quite solid data. Means every single time he watch the video, the analysis is going to be similar. The interpretation is going to be similar for all the indicators that he watch. So that's it, guys. The way for us to determine the reliability of our tester by using test, retest, reliability testing. That's all. Thank you. Assalamualaikum.